Welcome to this tutorial. In this tutorial, I would be solving the specimen paper of O Level Physics for the year 2023. And this specimen paper would be used to prepare for the examination of the May-June series. Uh, there is not much change in the pattern of the paper, except that the value of the G that is to be used from now onwards is 9.8 meter per second square. Otherwise, there are 40 questions in the paper. All the questions are to be attempted. There would be 4 possible answers in each question, and now we need to choose the one which we consider the correct. And there is a separate answer sheet in which it is to be recorded as the answer. Okay, calculators are allowed. We can use the calculators, and the total marks of the paper are 40, and still the paper has the time of 1 hour in which it is to be completed. Starting with the questions, question number 1 says a small cylinder is rolled along a ruler and completes 2 full turns as shown in the diagram. So this is the cylinder. It is starting at the mark 1.4. So let me write it down here. It starts its revolution when it was placed at 1.4. It took 2 full turns and then it finished at 10.2 mark. Now, the distance that it has covered is 10.2 minus 1.4, which is equal to 8.8 centimeters according to the figure given. We need to find out what is the circumference of the cylinder. So circumference is the equal to the length of the boundary of a circular figure. So since it has made 2 full turns, so the distance covered in 2 full turns is 8.8. We would be dividing 8.8 by 2. The answer would be 4.4 centimeters. So this option A would be the correct answer for the circumference of the cylinder. Question number 2, it says that which diagram shows the vector addition of a 4 Newton force and a 3 Newton force. So for addition of the vectors, we would be using the tip to tail rule or triangular rule. And according to that rule, we need to draw first vector. For example, we draw 4 Newton vector. Then on the head of the first vector, second vector is drawn. And the tail of the first vector is to be joined with the head of the second vector. So this vector would be the resultant vector. Now, if we analyze the figures given, for example, in part D, 4 Newton is drawn over here, but the head of the second vector is connected with the head of the first vector. So this is not in accordance with the triangular law. In part C, we see that first vector is drawn in this direction and the second vector is drawn in the vertical direction upwards. So their tails are connected basically. And this is not again the addition of vectors. In part B, we can see that the first vector is drawn 4 Newton and on the head of it, the second vector is drawn 3 Newton. But the problem here is that the direction of the resultant vector is not in accordance with the triangular rule. It should have been like this. So in part A or the choice A, the diagram or the vector addition is drawn according to the triangular law. First vector, then on the head of it, the second vector. The tail of the first vector is connected to the head of the last vector. So part A should be the answer of this question. Question number 3 says the diagram shows the speed time graph for an object moving with constant acceleration. Since it is moving with constant acceleration, so we can see that the line drawn over here is a straight line. The gradient of the line is constant. What is the distance traveled in the first 4 seconds? So we need to find out the distance traveled using a speed time graph. For that, we would be calculating the area under the graph. And if we see this figure which is being drawn here under this line, it is a triangle. So the area of triangle could be found out by using the formula half base into height. 1/2 base would be 4. This one would be the base, and this would be taken as the height of 6 meter per second. So it is 4 into 6, and the answer would be equal to 12 meters. So from the given options, C would be the correct option. Question number 4, it says an astronaut travels to Mars. Which row describes how his mass and his weight compare with their sizes on Earth? So as far as the mass is concerned, mass does not change anywhere in the universe. And the weight of the object is dependent on the value of the gravitational field strength. So the gravitational field strength of Mars is different from the gravitational field strength of the Earth. So out of the given options, we would select this one, that the mass is going to be same on the Mars as well, but the weight is going to be different. So the option C should be correct. Okay, question number 5, it says which object has the largest resultant force acting on it? In part A, there is a force of 30 Newton to the right and 20 Newton to the left. So it means there would be a resultant force of 10 Newton to the right. In part B, 10 Newton to the left, 20 Newton to the right. So it means again, there would be a force of 10 Newton to the right as the resultant force. In part C, 30 Newton to the left and 10 Newton to the right. So there would be a force of 20 Newton to the left as the resultant force. And in part D, all the forces are acting to the left. So their resultant would be 15 Newton to the left. So the largest resultant force that we are obtaining in this question is in the part C, which is 20 Newton, and the direction of the resultant force is to the left. Question number 6, it says a tractor pulls a trailer at a constant speed. So this is a very important information, that the speed of the trailer and the tractor is constant. So it means that there is no acceleration over here, and no acceleration means that the net force is also going to be 0. The tractor exerts a force of 1600 Newton forwards. Okay, so this tractor is exerting a force of 1600 Newtons in this direction, and this force is basically pulling the trailer. What force is exerted by the trailer on the tractor? So the force exerted by the trailer on the tractor would be the reaction of it, and the reaction force is always equal and in the opposite direction. So it should also be 1600 Newton. And from the given options, we can say that 1600 Newton backwards would be the best option here and the correct option. Okay, question number 7 says a skydiver is falling at terminal velocity. So terminal velocity is the highest velocity obtained by a falling object. And when the terminal velocity is obtained, the acceleration due to gravity becomes 0. Which row describes the acceleration of the skydiver and the velocity of the skydiver? So acceleration of the skydiver is not downwards, it has to be 0. So it could be either C or D. Now, according to the concept, the velocity of the skydiver should be constant. It should not change. So constant velocity and 0 acceleration describes the movement of the skydiver. So the option C would be correct here. Question number 8, it says which car experiences a resultant force that is not 0. So we need to find out, we need to select the option where the resultant force is not 0. First option, a car moving along a straight horizontal road at constant speed. So when a car is moving at constant speed and its direction is not changing, it means that there is no acceleration and no change of velocity, and the resultant force is going to be 0. Part B, a car moving around a bend at constant speed. Okay, now the direction is changing. Since the direction is changing, so there would be acceleration in the object and the resultant force is not going to be equal to zero. Part C says a car moving up a hill at constant velocity. Since the velocity is constant, so the resultant force is again going to be zero because the acceleration is zero. A car that is at rest, that is also that is the case where acceleration is zero and the resultant force is also going to be zero. So the part B would be the option which would be the correct in this scenario. Question number 9, a car is designed to be stable. So for stability, we always ensure that there are two factors present in the structure of some object. Number one is that its center of gravity is as low as possible, close to the ground. And secondly, the base of the object is wide. So where must the center of gravity of the car be? Above the front wheels, above the rear wheels, as high in the car as possible, as low in the car as possible. So this would be the option that we need to make sure that the center of gravity is as low as possible so that the stability of the car is increased. Question number 10, it says that the diagram shows a block being pulled up a ramp by a rope. So this is the rope which is pulling this block and a force F is being exerted. When the block moves, it covers a distance from P to R. And the vertical height that is gained by the block is given by QR. The block has weight W. This is the weight W. And the rope is pulled with force F. That force was being shown over here. The block moves distance PR and is raised through the height of QR. So this was the distance being covered by the block, and this is the height being gained by the block. What is the equation for the work done on the block by the rope? So the work done is defined as the product of force and the distance, and this distance is covered in the direction of the force, in the same direction as the force is being applied. So we would see that the work is being done under the influence of this force F, and the distance which is being covered in the direction of the force is this PR. So the block is moving in this direction. The distance being covered is PR. So out of the given options, force F and the distance PR would be the correct one. So this is the correct option, part A. Part B says force F and the height QR. So the height QR is not applicable over here. Weight and the distance PR. So these two options are also not correct. Part A would be the correct option. Question number 11, which uses a non-renewable energy source. So a solar panel is a renewable energy source, a wind turbine is a renewable, a geothermal heating system is also a renewable. Only the nuclear power station is not a renewable energy source. So this would be the correct answer for this question. Question number 12 says, which expression gives the efficiency of an AC generator? So in an AC generator, we do provide some energy as input and we receive electrical energy as our output. So the efficiency would be the total energy provided to the generator, and it would be in the denominator, and in the numerator there should be electrical energy which is being taken as the output. So the first option says electrical energy output, total energy input. This is the correct one. Electrical energy output, thermal energy output, this is not correct. Total energy output, electrical energy input, no. Thermal energy output, total energy input, this is not the correct one. So part A would be the correct option for this part. Question number 13 says mercury is a liquid. The diagram shows a simple mercury barometer, which height is a measure of the atmospheric pressure. So the atmospheric pressure is measured with the height which starts with the mercury in the beaker or the tray and the level of mercury in this tube. So this option C would give the measure of the atmospheric pressure, and other options are not correct. Question number 14, it says a gas in a sealed container at constant volume. So the volume is not going to change in this scenario. The gas is heated and the pressure of the gas on the wall of the container increases. How do the particles of the gas cause this increase in the pressure? They expand? No, this is not the correct one. They hit each other more frequently. It doesn't cause the pressure on the walls of the container. The pressure on the walls of the container is caused when the particles hit the walls of the container more frequently, not because of their internal collisions or the collision between the molecules. They hit the container walls more frequently. This should be the correct one. They vibrate faster. No, since they are gas particles, so the vibration is taken into account when they are solid, they are in the state of solid. So the correct option for this scenario would be option C. They hit the container walls more frequently and cause increased pressure. Question number 15 says a person cannot open a glass jar which has a metal lid because the metal lid is tightly attached to the glass jar. After the lid is held under hot water for a few seconds, the jar opens easily. So here is the hot water coming out of this tap, and it is being dropped onto the metal lid, and it is the glass jar which is on which the metal lid is tightened. What is the explanation for this? The glass jar contracts? No. The glass jar expands? Yes, it expands, but glass has a low thermal conductivity as compared to the metal, so it would expand, but it would expand later. The metal lid contracts? No. Since the hot water is being put onto the metal lid, so that hot water would transfer thermal energy to the metal lid, and then the metal lid would expand. So when it expands, it is untied from the glass jar very easily. So this is the correct option in this scenario, that the metal lid expands and it opens then. Okay, question number 16. It says the more energetic particles escape from the surface of a liquid. Which term describes this process? Condensation? No, condensation is not escaping of the particle. Evaporation? Yes, this could be the option. Melting? Melting is not the option here. Radiation is not the option. So the correct phenomena, the name of the phenomena which is taking place is evaporation. Question number 17. It says the depth of the sea under a ship is determined by sending a pulse of sound with a frequency of 3000 hertz from a transmitter on the bottom of the ship to the seabed. So there is a pulse of sound which is being used here, and the frequency of the sound pulse is 3000 hertz in this case. The sound reflects from the seabed and returns to a receiver on the bottom of the ship. The time between sending the pulse and receiving the reflected pulse is measured. So a pulse is generated, sent towards the depth of the sea. It is reflected, comes back, and then the receiver receives it, and it notices the time interval between the pulse being sent and being received back. The depth of the sea beneath the ship is 600 meters. So this distance between the ship and the seabed is 600 meters here. The time measured is 0.80 seconds. So in this time, the pulse went downwards towards the depth of the seabed. It bounced back and came back to the receiver within this time. So this distance between the ship and the sea was covered twice in this interval. So 600 into 2 is 1200 meters, the distance covered in 0.80 seconds. What is the wavelength of this sound in the sea? So in order to find out the wavelength, we would be using the formula V is equal to F lambda. We know the frequency of the sound. but we do not have the value of the speed of the sound. So in order to find the speed of the sound, we would be using the relation that speed is equal to distance upon time. Distance being covered by the sound waves is 600, and it is being covered twice, so it would be multiplied by 2 divided by the time, which is 0.80 seconds. So the speed comes out to be 1500 meters per second for the sound pulse being used over here. Now this value would be used in the formula above. So 1500 is the speed, 3000 is the frequency multiplied by the wavelength. So the wavelength would be equal to 1500 divided by 3000. So it should be 0.50 meters. So out of the given options, C would be the correct answer, that the wavelength in this case would be 0.50 meters. The next question, question number 18, it says light is incident on a mirror and is reflected as shown. Now the light wave is coming from this direction. It strikes the mirror over here. It is the point of incident and then it is reflected. According to the laws of reflection, this angle, which is angle of incident, measured between the normal and the incident ray, and this angle, which is being measured from the normal to the reflected ray, angle of reflection. So these two angles must be equal. Now the diagram tells us that this angle, which is being measured between the reflected ray and the ray which was prolonged here, the incident ray, is 80 degree. And as we know that its adjacent angle, this one, would be equal to 100 degree, which could be further divided into two parts. This would be 100 degree. And if I start measuring it from the normal to the incident ray, this angle would be half and the other half would be over here. So both of these angles would become 50 degree. Okay, what is the angle of incidence and what is the angle of reflection? Angle of incidence is measured between the normal and the incident ray. So this would be the angle of incidence, which is being measured from the normal to the incident ray, and it is 50 degree. And the angle of reflection, this angle is measured between the normal and the reflected ray. So this angle would be this one, and it is also 50 degrees. So according to the given options, option D would be the correct option in this scenario. Okay, next question, question number 19. It says an object O is placed in front of a lens. The ray diagram shows the path of two light rays that start at the tip of the object. So two rays are being emitted from the tip of the object. One is parallel to the principal axis, goes through the lens, and then it diverges. So it means that a diverging lens is being used over here. The other ray is coming and passing through the optical center of the lens and continues its path straight and undeviated. Now, the question is which point P or Q is a principal focus and what type of image is formed? Now, talking about the type of image, so since it is a diverging lens, so always a virtual image is formed. And which point is the principal focus? For that, we would be extending this ray backward. And by extending it, we can see that the principal focus should be this point, which is point P. Because when we extend the reflected ray backward, it seems to be coming from a point which is the point of principal focus, and this is according to the refraction which takes place in the diverging lens. So from the given options, we can say that option B should be correct, that the principal focus is point P and the type of image formed is a virtual image. Okay, question number 20, it says a sound wave travels through air. The lines in the diagram show the position of the particles of air at one particular time. which distance is the wavelength of the wave. So the wavelength would be the distance between two adjacent center of refractions or rarefactions or the center of compressions. It starts from the center of compression, but it does not end at the next compression. Instead of ending here, two compressions are being counted. So this does not represent the wavelength. Uh, in part C, for the distance C, the center of rarefaction and the center of compression, the distance is being measured between these 2 points. So this C is also not the wavelength. For the distance B, the center of rarefaction till the center of the next rarefaction is being measured. So this should be the correct one, and A is also not representing the wavelength of this sound wave. So this option would be the correct one here, part B. Question number 21. The diagram shows an electromagnet. How can the strength of the magnetic field around the electromagnet be increased? So for increasing the strength of the electromagnet, we can do one thing, that the current through this electromagnet should be increased, or the voltage from the DC supply should be increased. So the options are given options are remove the metal core and decrease the current in the circuit. No, when we remove the metal core, the magnetic field becomes weaker, and by decreasing the current, the magnetic field becomes further weaker. So this will not increase the strength of the magnetic field. Part B says, option B says remove the metal core and keep the current in the circuit constant. It will not also increase the strength of the electromagnet. Reverse the DC supply. Reversing the DC supply does not have any effect and decrease the current in the circuit. So this will also not help in strengthening the magnetic field. Reverse the DC supply, it does not have any effect, and increase the current in the circuit. So this one, doing this, that increasing the current would help increasing the strength of the electromagnet. So option D would be correct one out of the given options. Question number 22. What material can a temporary magnet be made from? So temporary magnet is made from soft iron. Plastic and wood do not make any magnet, and steel makes a permanent magnet rather than making a temporary magnet. Question number 23. It says the diagram shows an uncharged ball covered with metallic paint. The ball is suspended from an insulating thread. It is placed near a positively charged rod. Which diagram shows the charge distribution on the ball? Now, since the ball is being attracted by a positively charged rod, so there would be a buildup of negative charge near this positive charge, because these positive charges are attracting the negatively charged electrons. And the deficiency of the electron in the opposite phase would induce a positive charge in the opposite side of the metal ball. So out of the given options, option D would be correct, that a negative charge would be built up near the positively charged rod, and a positive charge would be built up in the opposite side of the sphere. Question number 24. It says a charge of 45 coulomb flows through an electric appliance in 3 minutes. What is the average current in the appliance? Okay, so we are given with two quantities, charge and the time. So the formula which could be used here is current is equal to charge divided by time. Charge being flown is 45 coulombs, and the time is 3 minutes, which should be converted into seconds by multiplying it with 60. So it would become 1 upon 12, and this would be equal to 0.25 amperes. So out of the given options, option A would be the correct option, that the current would be 0.25 amperes. Question number 25, it says a wire of length 0.5 meters and cross-sectional area 1.0 into 10 raised to minus 6 meters square has a resistance of 0.75 ohms. Okay, so resistance is given and it is found out using a formula which is rho L upon A. So if we drive it for the resistivity, it would become R A divided by L. So using this formula, we can find out the resistivity for this metal. Next part of the question says another wire of the same material. So material is same, which means that the value of resistivity is not going to change, has a length of 2 meters and a cross-sectional area of 0.50 into 10 raised to minus 6 meters square. What is the resistance of the longer wire? Which means that they're asking the resistance of 2 meters wire, which is the longer wire. Okay, so the resistance would be equal to rho into L upon A. And rho could be replaced as RA upon L into L upon A. The values over here were 0.75, which was the resistance of the earlier wire, and the area okay. I'm replacing the values over here to find out the value of resistivity. It is 0.75, the resistance of the earlier wire, and the cross-sectional area was 1.0 into 10 raised to minus 6, and the length of the wire was 0.50 meters. Okay, so these values could be replaced over here also. R is 0.75, area is 1.0 into 10 raised to minus 6, divided by the length 0.50. Now the length of the second wire is 2.0 and the area is 0.5 into 10 raised to minus 6. Now after simplification, we get the answer of this whole expression as 6 ohms. So the resistance that we needed to find out comes out to be equal to 6 ohms. And from the given options, option D is correct over here. Okay, question number 26. It says, which electrical symbol represents a fuse? Part A represents a light emitting diode. C is a motor. D is a lamp. So part B is the symbol of the fuse, which is the answer of this part. Question number 27, it says 3 identical resistors. Identical means their resistances are same, are joined in series to a battery. Okay. In a series circuit, current remains the same and voltage is divided among the components. And if all the components have same resistance, then the voltage is equally divided. Voltmeter Q reads 8 volts. Okay, so the voltmeter which is connected across these two resistances, it reads a reading of, it gives a reading of 8.0 volts. What is the reading on voltmeter P and what is the EMF of the battery? Okay, since the resistance of all the resistors are same and the voltage across these two resistors is 8, so the voltage across this single resistor would be equal to 4.0 volts. And if we add up all the voltages, 4 plus 8, the EMF of the battery comes out to be equal to 12 volts, because this was the total voltage which was being divided amongst these 3 components. Now, out of the given options, voltmeter reading on P should be 4 and the EMF should be of the battery should be 12. This should be the correct answer for this part. Question number 28, it says the EMF of the battery in a radio is 3 volts. The resistance of the circuit in the radio is 6 ohms. The radio is switched on. How much energy is transferred from the battery in 30 minutes. Okay. Energy transferred can be calculated by the formula E is equal to VIT. Now, the value of the voltage is known, but the value of the current is not known here. T is also known. So first of all, we can find out the value of current by using the relation V is equal to IR, which means V upon R will be equal to I. The voltage is 3.0, resistance is 6.0. So it means the current is 0.50 amperes. Now, by plugging in the values over here, this value is 3.0, this is 0.50, and the value of time is 30 minutes. So 30 multiplied by 60 in order to convert it into seconds. And the value we get after multiplying all the values is 2700 joules. And from the given options, this option C would be the correct one. Question number 29. What is the unit of the energy used by an electrical appliance? So ampere is the unit of the current, volt is the unit of the voltage or potential difference, watt is the unit of the power, and kilowatt hour is the unit in which the energy used by an electrical appliance is measured. Question number 30. A magnet oscillates vertically above a coil of wire. So this is the magnet which is being made to oscillate using this spring, and this is the coil of wire. As the lower end of the magnet oscillates between P and R, a varying EMF is induced across the coil. So the lower end of the magnet is moving towards the coil and then moving away from the coil. And because of this movement, magnetic flux is changing. And due to this change in magnetic flux, the coil of wire is being induced by an EMF. So an EMF is being induced in this coil of wire. When this EMF is 0 volt, where could the lower end of the magnet be? So the magnet starts moving from this position Q, goes to R. And this is the maximum where it can go. So it stops for a moment at R, and then it starts moving back and moves till P. It again stops for a moment at P, and then reverses its direction and moves downwards. So in this whole to and fro movement, in this movement, when the magnet goes downwards and then moves upward and then again goes downwards, it stops for a moment at R and at P. When it changes its direction, it reverses its direction of movement. So this stop causes, and stopping for a moment causes, the EMF to be equal to 0 volt. And when the magnet keeps moving, the EMF is not 0. When it stops for a moment, the magnet, the EMF induced because of this magnet becomes 0, because there is no relative movement of the coil and the magnet for that particular moment when the magnet was stopped. So out of the given options, we can say that at P or at R, the EMF would have the value of 0 volts. Question number 31. Which transformer arrangement produces an output EMF that is larger than the input potential difference? So for a larger output, the transformer should be a step-up transformer. And in a step-up transformer, the number of turns on the secondary side should be greater than the number of turns on the input side. In part A, we can see that there is a DC input. So no EMF would be induced in this output coil, because to induce an EMF, there should be an AC supply connected to the primary side of the transformer. Now, an AC supply is connected, and we can see that the number of turns on the input side or the primary side are lesser, and the output has a larger number of turns. So this should be the one where we can get the larger output from the transformer. In part C, again, we can see that a DC input is connected, so EMF will not be induced on the output side. And in part D, we can see that AC input is connected, but the number of turns on the primary side are larger than the number of turns on the output side. So the transformer would work as a step down transformer rather than working as a step up transformer. So option B is the correct option over here. Question number 32, it says, why is a relay used in a switching circuit? So options are to switch on a small current using a small current, to switch on a small current using a large current, to switch on a large current using a small current. So this is the correct option. Relay is used so that the relay circuit is operated using a small current, and as a result, the circuit being switched on, there is a large current flowing in that main circuit. So relay circuit uses a small current and it switches on a large current, which is to be used in the main circuit. Option D is to switch on a large current using a large current. This is also not correct. So option C is the reason why the relay circuit is used in the circuits, especially where large current is to be flown. So rather than switching on and off using a switch, a relay is used for the better operation of the circuit and the safety. Question number 33, it says a horizontal beam of electron passes between two poles of a magnet in a vacuum. So here is the magnet. Magnetic field lines would be coming out of the north pole, entering into the south pole. And then there is a beam of electron flowing in this direction. In which direction is the beam deflected? So the beam would be deflected in the direction where the force is acting on the beam. To find out the direction of the force, we would use Fleming left-hand rule in this scenario. And Fleming left-hand rule, the index finger represents the direction of the magnetic field, which is in this direction. Similarly, the middle finger represents the direction of the charge flowing, and that is the conventional current. So conventional current or the positive flow of the charges would be in the opposite direction as the direction of the beam of electron is given. So the direction that comes out to be is into the page for the positive charges, and for the beam of electron, it would be opposite and it would be out of the page. So the correct option in this scenario would be out of the page. Fleming left-hand rule is used for the conventional current or the positive charges, and for the beam of electron, the opposite direction, which comes out to be the direction of the force for the positive charge, is taken. So for the positive charge, the reflection would be into the page, and for the beam of electron, it would be opposite to that and would be out of the page. Question number 34, it says how many neutrons are in one neutral atom of the krypton isotope? So to find out the number of neutrons, we would take the mass number or the nucleon number and subtract proton number from it. And so the answer would be 48 over here. Question number 35, it says carbon 14-6 represents a nuclide of the element of carbon, and 14-7 nitrogen represents a nuclide of the element of the nitrogen. How is a neutral atom of nitrogen different to a neutral atom of carbon 14? So if we analyze the details of carbon 14-6, it means that number of protons are 6, number of electron would also be 6 since it is a neutral atom, and number of neutrons would be 14 minus 6 equal to 8. And the details of the nitrogen would be protons are 7, electrons would also be 7, and neutrons would be equal to 7. Now this is the detailed analysis of the particle. Now the option says the nitrogen atom has 1 electron fewer than carbon atom. That is not correct. Nitrogen has 1 more electron than carbon. The nitrogen atom has one neutron more than the carbon atom. It is also not correct. It has one fewer neutron. The nitrogen atom has one proton fewer than the carbon atom, which is also not correct. It has a larger number of protons. The nitrogen atom has one proton more than the carbon atom, which is correct because the number of protons over here are 7, which is one more than the carbon possesses. So the correct option here would be option D. Question number 36, it says radioactive isotopes emit three types of radiation. Which list gives the type of radiation in order of their ionizing effect from greatest to least? So ionizing effect depends upon the charge possessed by the type of radiation. And the largest charge possessed is by alpha particles. So they have the highest ionizing power. And then there are beta particles, and the least power possessed is by gamma rays. So this is the correct order of the radiation as far as the ionizing effect is concerned. Question number 37, it says, which statement about the half-life of a radioactive isotope is correct? Part A, half-life is half the time it takes for the mass of the isotope to decrease to zero. So this statement is not correct. Mass of the isotope to decrease zero. Half-life is the half the time it takes for the number of nuclei of the isotope to decrease to zero. No. Half-life is the time taken for the nucleon number of the isotope to half. No. Half-life is the time taken for the number of nuclei of the isotope to half. Yes. So this option is correct. This is according to the definition of the half-life, that it is the time taken for the number of nuclei of the isotope to half and become stable. Okay, question number 38. Light from the sun travels to Earth at a speed of 3.010 raised to 8 meter per second. The time for the complete journey is 500 seconds. What is the average orbital speed of the Earth in its orbit around the sun? So if we want to find out the orbital speed of the Earth, we need to find out the distance covered by the Earth, which is equal to the circumference of the orbit of the Earth around the sun, divided by the time taken to complete this one orbit. Now, for finding out the circumference, we need to find out the value of this r, the radius. And for finding out this value, we would be using these two given information, that the speed of the light is 3.010 raised to 8, and it takes a time of 500 seconds to reach from the sun to the earth. So the distance it would be covering would be equal to the radius of the orbit of the earth around the sun. For example, earth revolves in this circle. Here is the sun, and we can consider the earth over here. So the distance between the sun and the earth is actually the radius of this orbit of the earth around the sun. So light starts moving from the sun and moves at a speed of 3.010 raised to 8 meters per second and takes 500 seconds to reach the earth. So it means that it covers a distance of 1.5 into 10 raised to 11 meters to reach the earth. This distance would be taken as the radius of this orbit. So I'm replacing the value over here. It would be 2 pi into 1.5 into 10 raised to 11. And the time taken to complete one orbit is 365 days. It should be multiplied with 24 to convert it into hours, and then 3600 to convert into seconds. So the answer would be 29885.7 meters per second. which could be approximated to 30,000 meters per second. And this would be 3.0 into 10 raised to 4 meters per second. So from the given options, we can say that the option C is the correct option for this part. So this was the question from the space physics where the orbital speed of the Earth was to be found out. Question number 39. In the sun, energy is transferred from an energy store. Which energy is being released and what is the name of the reaction that releases this energy inside the sun? So inside the sun, fusion reactions take place where two nuclei of the hydrogen combine and form a larger nuclei, and this energy is the nuclear energy. So this option D, nuclear energy and fusion, is the correct answer for this part. Okay, the last question. The light emitted from a galaxy is redshifted when detected on Earth. How does the frequency of the light when detected on Earth compare with its frequency when emitted, and in what direction is the galaxy moving? Okay, so when a light emitting source moves away from something, for example, the galaxy is emitting the light and it is moving away from the Earth. So this away movement reduces the frequency of the light. And when the frequency of the light is reduced, the color of the light is shifted towards the red. So this phenomena is called the red shifting, because the light source is moving from the observer or from a specific planet, and the observers of the planet can see that the frequency of the light is reducing, so the color of the light seems to be red. So we can say that the frequency of the light when detected on Earth is actually lesser than the frequency emitted of emission. And the galaxy is also moving away from the Earth. That is why the red shift is taking place. So the option A would be the correct option here. So the paper, specimen paper has ended here. Hopefully it will help you in preparing for the exams, and you can share it with your classmates also. Thank you for watching.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.